What's up, everybody? My name is Joshua Evans, and this is the next number 2 of the series Projects of a Lifetime, where I basically go through my entire experience, almost half my life of doing electronics, programming, engineering, and computer science, all that stuff, and I showing off and explaining the significance of the projects I've done over these years. So in the first video, I explained my very first experience with electronics, and that was the electric motor, and how this kit was absolutely terrible because the kits were so bad back then. And I made this kit and nothing in the kit worked except for this one thing, the electric motor. And we made this and it was fantastic. It worked perfectly, this motor. And the explanation was bad. Everything else about this project was bad, but it showed me that even with just a few common household things, you can make the device that began the electronic revolution kind of thing, because the motor is almost, you can say, the father of all other electronics. It's a generator. Motor is a generator. So I don't know, that was just amazing. But in this video, this is the next video, I explained how I made a touch lamp. And now this is a few years after doing it. I didn't actually make that much progress in the beginning years. This was about 1 or 2 years after the very first experience with electronics. And basically the story goes like this. Me and my family, we went to Florida, I think it was, and we stayed in a hotel. It was a nice hotel, and I got my own room. And you jump on the bed and you just stretch out. It's that hotel smell. It was great, and the nice crisp sheets and all that stuff. And I went to turn on the light, but the light didn't actually have a switch. And I was trying to figure out, how in the world do I turn on this lamp? How do I turn on this lamp? And turns out you just touch the side of the lamp. You've probably seen one of these lamps before, but you don't have to touch it. There's no button. I mean, you have to touch it, but there's no button. There's no switch. You just touch the side of it, any side of this lamp, and it turns on. And I sat there pondering, how in the world does this machine work? How does this thing turn on? How does it recognize my finger? And I just sat there thinking about the things I've learned so far. Transistors, resistors, integrated circuits, the timer 555 chip, capacitors, batteries, wires, all that stuff. I was just thinking, and I realized I know everything I need to know to make this thing work. I can make this thing. I understand. I think I know how it works, and I think I can make it. So, the rest of the vacation was great. Had a fun time, but as soon as we came back, I ran straight up to my room in my newly formed kind of lab with a bunch of basic components and all that stuff. And I got to work and I started building it. It took me a few hours, but finally I made this circuit that did not exactly, it didn't do exactly, I kind of cheated a little bit, but it did pretty much what I wanted it to do. Be able to turn it on and off a light bulb without actually having to press a button or flick a switch or anything. Just, it works. So I made this circuit again. This is it. And this is the circuit right here. So we have some transistors, we have the timer 555 chip. And basically the way this works is, the process I was thinking back then was, okay, your body is an extremely weak conductor, and it has a bit of a charge to it. You're basically a sack of water, which is able to carry a tad bit of electric charge, and it's also a conductor. If you're able to put electricity through your finger, right, and then pick it up and amplify it, you can use that to turn on and off an LED. And the way you turn it on and off is by using a chip called the timer 555, and you can look it up. And there's 3 main modes. There's monostable, there's astable, and there's bistable. Astable basically means it's not stable. It's never stable. It's always flicking between the two. It's an oscillator. It goes back and forth, and you can change how fast it goes. That's astable, never stable. You have monostable, meaning it's stable in one position. So let's say it's stable when it's off, right? So when you turn it on, after a period of time, it turns back off. It's not stable. It's going to change. And then once it reaches that off state, it stays off. So that's monostable. Bistable is the thing I needed, meaning it's stable both ways. If you turn it on, it'll stay on. If you turn it off, it'll stay off. And I use these to make my circuit. So this is the circuit right here. This is the circuit. I already showed it, right? As you can see, there's no buttons, only these diodes that I kind of cut and then twisted around so it makes a nice little platform that I can put my hands on, right? And I'm going to connect the power. There's no buttons. This circuit I made about like 5 years ago, so it's still extremely simple, very, very simple, but it demonstrates a portion of my life that really changed how I looked at the world and electronics. So touch one, turns on, touch the other. So yeah, that's pretty cool. There's this wire hanging out right here. That's not a mistake. I'm basically conducting the electricity through my hand and my body and all that stuff and picking it up on here. But because it's extremely low voltage, low current, low everything, it doesn't actually hurt me. It doesn't do anything. I can't feel it. Nothing's happening. But a tiny bit of current is running through my fingers. And if you want to be 100% safe, if you're going to make the circuit, I'll leave the diagram in the description and all that stuff. But if you want to be extra safe, use it with one hand so it's not going across your heart. If you're spooky about that, you won't actually get hurt, but you know. And here's another thing. You can I was saying before that your body is actually a capacitor and it has the ability to store charge, right? What you can actually do is keep your, I don't know why I brought this back up here. You could keep your finger on here, right? Let your body build up some charge, and then without even having to touch it, it still turns off. You won't be able to do it again until you charge. Charge. My hand is off. You see that? So your body is a conductor, and I think 2 projects from now, I'll be using this phenomenon to make something that almost looks like magic, that looks almost like sorcery. It's pretty cool. But using the concept that your body is a capacitor, your body has the ability to store a tiny bit of charge. You can't do anything too much with it without amplifying it a bunch. But stay tuned. Not the next one, but probably the next one after the next one. I'll be using that, right? And I'll explain it more. I was trying to make a radio, and I didn't make the radio. It didn't work. It took me a couple years to make a radio, completely from scratch. But in trying to make a radio, I actually ended up making something else that is pretty cool, or pretty sci-fi almost. But that's the end of the video. Wait, no, I gotta explain what this gave me. So this basically gave me it was kind of a positive and negative thing, because when you look around and you see all this technology, all this cool stuff doing awesome things, it's almost like magic. But once you understand that all it is some guy or some girl or whatever made this device, put their heart and soul into it to make this device, and then now it works. Instead of it being, it just works, it just does what it does. So it kind of took away a little bit of the magic of the world we live in, but it also gave me this thought process, this ability to say, these things, if I have an idea, I can actually make it. If I have an idea, all I have to do is learn how to do it, right? Discover how to do it or whatever, and I can actually make that idea. Now it's crucial in engineering and creation in general. You have to have a feeling and a thought process that you can actually make something. So, yeah. So stay tuned in the next video. The next video, I'm going to be talking about how I made a really simple divider, if you could call it that. It's really simple, but it's basically a divider using nothing but transistors and logic and all that stuff. So stay tuned for that video. Make sure you comment, like, and subscribe, and have a great day.